We're following our exponential equations, and we're going to be solving using logarithms and going through these three steps. First, isolate the exponential. Depending on how the exponential is hooked to other numbers, is going to depend on whether we add or subtract a number away or divide it off. In this case, since the 10 to the 3x, the exponential is hooked to the 10 by multiplication, we're going to divide both sides by 10. So we have 10 to the 3x equals 10. All right, now get rid of the exponential by converting to a log. So it's going to be log base 10 of something equals 3x. And again, the power is always on the other side of the logarithm. What goes inside is 10. And remember, it goes back to if they're together here in the exponent, they're not going to be together here in the logarithm. So since this is base 10, I can just use my calculator and plop in log. And I don't have to type in the base because my calculator already knows that's base 10. So log of 10 is 1. So 1 equals 3 times x divided by 3, and I get x equals 1/3. They want me to round this to 2 decimal places, so 1/3 is approximately 0.33 as a decimal. Okay. For letter C, again, here's my exponential, but I do have an addition problem. So the 2 has to move by using addition-subtraction property. Since it's a positive 2, we're going to subtract 2 from both sides. This is now 3 times e to the x equals 6. To get rid of the 3, it's hooked by multiplication, so you divide it off. So we have e to the x equals 2. It's an exponential, so just get in the habit of writing a logarithm down. Log base e of equals, and then just fill in the blanks. So again, it's e to the x, so it's going to be log base e of 2 equals x. Log base e, though, is natural log. That's the button that's on my calculator. So then I can go to my calculator, press in ln2, log base e of 2, and it's 0.69. Right. Let's take a look at letter B. So again, I see an addition problem, so I'm going to have to use addition-subtraction property to get rid of the 10. It's positive 10, so take away 10. It's an exponential, so I use the word log. Bring down the base. And then once again, fill in. Well, if it's 5 to the 2x here, it's not going to be 5 and a 2x here. It's going to be 90. And the 2x goes on the other side. That's 2 times x, so to unhook that, I've got to divide it to both sides. And then using your calculator, and again, depending on whether you've got the log base button on your calculator or not, depends on what you're going to do next. I've got to use my change of base formula, so I've got to use log 90 divide log of the base. Base always goes on the bottom. And then take that decimal and divide by 2. So I get about 1.397. The 7's going to bump the 39 up to 40, so x is about 1.40. For letter D, I still see an addition sign, so I've got to use addition-subtraction property first. Exponential, so I'm going to use a log, bring down the base. And again, e to the 2x can't be together here, so this is going to be a 10, and the 2x goes on the other side. A logarithm's equal to the power. Right? Log base e is natural log of 10. That's just another name for log base e is ln. And then divide by 2 to get the x by itself. And when I divide by 2, I'm not taking 10 divided by 2. This is natural log of 10. So I've got to figure out with my calculator what is natural log of 10 and then divide that by 2. So about 1.15.